All right, reviewing chapter 10 for our final. The first one here says it's a circle. What can we tell from that circle equation? Okay, center is 3, -4, and the radius is 6. So we would plot our point, 3, -4, and we would go out 6 spaces in each direction. And then we would draw our circle in. Okay? All right. Second one, it says it's an ellipse. What do we have to do to get started on this one?
Divide off 100.
Yes. If we divide everything by 100, we end up with x plus 1 quantity squared divided by 25 plus y minus 2 quantity squared divided by 4. All right. So in an ellipse, how do we know which one's A and B? The bigger one's A. So in this case, A would have to be 5 because 25 is bigger than 4. So A is 5, B is 2. A goes with X and B went with Y. How did we find C? Okay. A squared minus B squared. So 25 minus 4. We've got the square root of 21. Which one does that go with? Goes with X. It goes with the same thing as A did, right? Okay. So can you figure out the center from the equation? Center would be -1, 2. All right. So let's graph our center. We know we want to go 5 in the X direction. So we can plot our vertices. What are the coordinates of those vertices? We're adding 5 to our X coordinate. Okay, -6, 2, and 4, 2. All right, then we're going to go 2 spaces in the Y direction. Those are our covertices. What are the coordinates for that? If we add and subtract 2 to the Y coordinate. All right. We can draw the ellipse in. The other thing that we're asked to find for an ellipse is the foci. We are using the square root of 21. We're pairing it with X. So we're going to add and subtract the square root of 21 to our X coordinate. So we have -1 plus minus the square root of 21. And the Y coordinate for our center was 2. What is the square root of 21, roughly? Somewhere between 4 and 5? Okay, so from our center, we're going to go somewhere between, say, 4.5 spaces, right? So our foci are real close to our vertices. All right, questions on the ellipse? Okay, hyperbola. How do we tell if something's a hyperbola? This one I told you it was, but what's the clue? The subtraction sign. All right, we're going to divide out the 144. We end up with y plus 1 squared divided by 9. X minus 4 squared divided by 16. And in a hyperbola, how do we know which one's A? It's always first. So in this case, A would be 3, and it's paired up with Y. B is 4, and it's with X. C, how do we find C? Okay. So we have 16 plus 9, A squared plus B squared. 16 plus 9 is 25. Square rooted would be 5. And it's going to go same way the A did, right? In the Y direction. Okay. Center for this one. And that's the common mistake, right? So when I talked about the final is going to have us working through with common mistakes. What is your x-coordinate of your center? 4, not the -1. That's the y-coordinate. All right, so make sure you have it in the right order. So we're going from 4, -1. We said we want to go 3 spaces in the y direction. Those are the vertices. What are the coordinates of those vertices? We are adding and subtracting 3 to our y-coordinate. So adding 3 gets us 2, subtracting 3, -4. Okay? Then, what do we do with the b? How do we use b? We need to make the box. Yep. So we're going to go 4 in the x direction. We're going to make our little box connecting the vertices and those extra points. We're going to draw in the diagonals. And then we need to draw in the hyperbola. Remember, the hyperbola has to go through your vertices and approach those asymptotes. All right, so the other parts that we still need to list, foci and asymptotes. Our foci, we said, are going 5 units in the y direction. So if we add and subtract 5 to our y-coordinate, we get what? Add 5, what do we get? Okay, subtract 5. Okay, so we have foci at 4, 4 and 4, -6. And then for the asymptotes, remember it's always that y equals mx type of equation? Okay, so our y piece was y plus 1 equals plus minus our slope. What is the slope of that diagonal? We're going up 3 and we're running 4, so 3/4. And then the x part was x minus 4. We're getting those right from the equation. Okay. The last shape that we need to review is the parabola. If it is a y squared in your equation, which way does it open? Is it left or right or up or down? It's the left and right kind. All right. The fact that that's negative tells me what? It's going to go left. All right. So we know this parabola has to open to the left. What I circled here, the -12, in our generic equation, we usually have a 4p in that spot, which tells me that p has to be -3. So it's a left kind. It's opening to the left where the distance from vertex to focus is 3 spaces. Okay? What is the vertex? And the common mistake on this test was people called this the center. Remember, there is no center in a parabola. Your vertex comes from your HK. So what are my values? -2, -4. All right, so let's graph that. -2, -4 is your vertex. Our focus has to go 3 spaces to the left of that. So what are the coordinates of that? Okay. And then the other piece that we always put down for a parabola was the directrix. That's your line, right? So we need to go 3 spaces to the other side of our vertex. So we would have a line here. What are the equation for that? x equals 1. Okay? Then, do you remember how we found out how wide to make the parabola? We used 2p from the focus, right? So 2p in this case would be 6 spaces. So 6 spaces up and 6 spaces down. All right, questions on conic sections? All right, chapter 11 dealt with all of our sequence and series formulas. This is the one that I said I will give you a half sheet that has the formulas on, but remember it will not be labeled. Okay, the formulas will be there, but I'm not going to tell you what they're for. Okay, so let's go back and see if we can generate those formulas. All right, so for arithmetic, if we wanted an explicit formula, we have a sub n equals, anybody remember? A sub 1 plus how many d's? If we're starting with the first term, n minus 1. Yep, we're always off by 1, right? Because we already know the first term. Okay. Geometric. What does it look like? A sub n equals yep, a sub 1 times r to the n minus 1. Okay? Those are your explicit ones. The recursive ones. Those are the ones where we build off the previous term. Okay? So we always state what the first term is. Doesn't matter if it's arithmetic or geometric. We have to give the first term if we're going to build off of it. And then for arithmetic, every term after that is found by taking the previous term and doing what? Adding our common difference. Okay? Geometric, any term is found by taking the previous one and multiplying by our common ratio. Okay, so those are the formulas that help us find a specific term in our list, or they help us come up with that rule for the sequence. Okay, then we had some summation ones. For the arithmetic sequences, we took all of our terms, however many terms we were adding up, and we paired them up, right? And each pair had a sum of the first term plus the last term. Now that is for finite, right? If it's an infinite one, we can't do it. For geometric, for finite sequences, we take our first term times 1 minus r to the nth power divided by 1 minus r. Okay. If it's infinite, first term divided by 1 minus r. But the restriction is we can only do that if the absolute value of r is less than 1. So we need things for r like negative 1/2, positive 1/3. Okay, our numbers have to be getting smaller as we go, meaning our sequence is converging. Okay? All right. So let's use those formulas. It says find the first 5 terms. Now here we're being given a formula for our sequence. They're just saying generate the first 5 terms. So we need a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. All right, we're just plugging those numbers into our formula. So first term would be 3 times 2 times 1 minus 1. Second term, 3 times 2 times 2 minus 1. 3 times 2 times 3 minus 1, etc. All right, so first term, 2 times 1 is 2, minus 1 is 1. 1 times 3 is 3. Second term, 2 times 2 is 4, minus 1 is 3. 3 times 3. Third term, 2 times 3 is 6, minus 1 is 5. 5 times 3 is 15. What do you get for the last two? 21 here and 27? Okay. Question 2. Write a formula for the nth term of the arithmetic sequence and then use the formula to find a sub 20, the 20th term. So if we're going to write a formula, we have to know the first term and we have to know our common difference. Are we given the first term? Yes? All right, we know a sub 1. Can we figure out how much we are adding each time? Each time we're adding 7. So our common difference is 7. All right, so our rule would be first term plus n minus 1 times our common difference. We said the first term was negative 2, and our common difference was 7. What do we get if we simplify that? Distributing the 7, we get 7n minus 7 plus the other negative 2 would be negative 9. Now, can we use that formula to find the 20th term? Just like we did in the previous question, we plugged 20 in for n. So our 20th term is 7 times 20 minus 9. 7 times 20 is 140 minus 9. Question 3, find the sum of the first 83 terms of the arithmetic sequence. Okay, this time we need our summation formula. So what of those pieces do we know? We know n. N is what? 83. They said add up the first 83 terms. So we're going to put an 83 in for n. What else do we know? Okay, we know our first term is 12, so we can dump that in for our first term. What's the one thing we don't know? Our last term, which in this case would be the 83rd term. Okay, so before we can actually calculate this, we have to figure out a sub 83. Okay, we are going to basically use that same formula we had in our previous question. Our first term is 12. What's different now is I know what n is. Okay, I know n is supposed to be 83. So I can plug an 83 in there, 83 minus 1. And in this example, what's my common difference? What am I going up by? 3. All right, so let's calculate that. 12 plus 82 times 3. What do we get? Say it again. Anybody else get that? 258? Okay, so we can now dump that in for our last term. All right, so summing 83 numbers. We have 83 divided by 2. Our first term we said was 12, and we just found our last term to be 258. Go ahead and get your total. All right, 11,205. for your sum? Okay. Shifting to geometric sequences, find the nth term. So they want that generic formula for a sub n. For geometric, it's first term times r to the n minus 1. Do we know a first term? Yes. Do we know r? All right, so it's very easy to just dump those in. A sub n equals 7 times 2 to the n minus 1 power. Okay, that's our formula for the nth term, or our rule. Then it says find a sub 23. So we can put a 23 in for n. So take 7 times 2 to the 22nd power. Seven times 2 to the 22nd power, which is not the same as 14 to the 22nd, right? Only the 2 is being raised to the power. We should be getting 29,360,128. Okay? Last question. Find the sum of the first 15 terms from that previous question. So, is this finite or infinite? Finite. They told me. I'm just adding the first 15 terms. Okay? We've made it finite. It's a geometric finite sequence. All right, so there's our formula for summing a geometric finite sequence. Do we know all the pieces that we need for that? Okay. How many terms are we adding up? 15. So we're summing 15 terms. Our first term was 7. Our R value was 2. We're summing 15 numbers, so our n value is 15. Go ahead and grab your calculator. Figure out your total. All right, total is 229,369. Yes? All right.